Nice to be invited here. It's my first time in Sarajevo. I am glad that I am among the last speakers because I have seen a lot of things about IoT, about cloud, about platforms. Well, I come from a different expertise. I come from utilities. Utilities are very conservative. They don't like cloud. They have IoT for many years now. They were calling it SCADA, telecontrol, remote control, but it's pretty much the same thing. So my presentation today is about an RTU, which stems from remote terminal unit. Basically, it's a control unit to connect a distribution grid, energy distribution grid. So this product that we are showcasing is at a third generation. It's actually fourth generation, Internet of Things SCADA Gateway. It actually very quickly consists of a virtual architecture for distribution automation. And it is a smart grid IoT gateway. In the distribution world, in the energy domain, basically they are interested in controlling the grid, in knowing everything about their assets and about their current consumption, about the power, how it's being distributed, what is the quality. And last but not least, we are empowering the utilities to make application management using directly the Cisco Fog. Cisco is already a strong partner in all the utilities all over Europe, all over the world. So they already are familiar with managing through Cisco application their core IT infrastructure, their core networks. Now, in the utilities, they always like to say the smart grid. Smart grid is the, let's say, the top word like the IoT. Actually, it's not smart and connected world. When they started looking at the platforms and at the operations in a utility, they come up with several models. One of these is done by the US agencies. So they are speaking about several domains: markets, operations, service providers, transmission, distribution, consumer, and generation. It seems like they are independent domains and they are islands in a way. But if you go deeper, unfortunately the contrast is not so good. If you go deeper, you can see that each of these domains actually consists of very small independent systems. SCADA is among the center of the operations. You have distribution management, then you have generation, then you have production, then you have markets, then you have customers. In theory, these are all independent systems. But if you look actually better and you need the good results, this is how the pictures looks like. So each of these systems need to talk to each other, need to be connected to each other. Some of these systems are regular IP systems, are the stuff that usual IT companies know. Some of them are non-IP systems. Like, for instance, devices in the field which only have a serial bus, which only have a very old protocol, if they have anything. So the problem with having this in place, and this is a recommendation for smart grid cybersecurity from the US market, is that the SCADA system has not been built in a day. This system has been built in years, maybe tens of years. It is estimated that the SCADA in energy has started about 50 years ago. So what is the current SCADA environment? How does things look like now? Well, you can see a lot of vendors in the market. Depending on each country, some are more present, some are less. But you can see ABB, you can see Schneider, you can see Siemens. In the US market, Cell, and I don't know, in the in the West Europe, Ziv or FASEC, which are more local companies. So each equipment has its own age, its own characteristics, its own protocol, so it speaks its own language. Each one has its own software, which is embedded for a specific hardware. For instance, if you want GPS location, you need to buy a GPS, a new hardware. If you want an additional function, you need to buy an additional hardware. So this is the case in most of the traditional SCADA systems. They are robust, they do the job, but if you need something else, that's it, you need to buy another box. And one other aspect which is very important is that the software solution is in many cases dependent on the vendor. So there are no necessarily universal versus software solutions like it's Azure for cloud, for IoT, or whatever other solutions for IT. Next to all these issues, you have to keep in mind that the energy sector is a regulated sector. So it's not a free market. Nowhere in the world it's a free market. So it has some regulatory bodies which says that equipment should stay in place for many years because population is paying for it. It should have a lifespan of 10 years. All the presentation here have spoke about release cycles of 6 weeks, days, months. So how could you put a company, keep something there for 10 years? Also, until recently, SCADA had two main issues. It needed to be reliable, and it needed to be open, to be connected. Well, this comes with backfire, because now the SCADA is open, and it is connected, but it is not secure. Because SCADA systems are meant to be open, are meant to be standardized so that any vendor can connect. And we have seen in the past several cyber attacks. It's not one. The Stuxnet, it's very well known, but there has been another in Ukraine. There has been a second one in Ukraine. There has been attempts in Finland. So there are a lot of attacks. Some of the most popular attacks are targeted towards the population, let's say, devices, like semaphores. You know, there has been an attempt to put all the semaphores on a red or on a green. So there are a lot of interest in terms of cybersecurity. But SCADA, by definition, was intended, because SCADA comes from system control and data acquisition, was intended to acquire data. So it was open. Now you have to face these challenges. What we wanted to come up with is to combine SCADA and ITC, because the challenges of SCADA have been the challenges of IT some 10 to 15 years ago. So it has been a lot of development ongoing. In order to do that, the current advances and the current technologies can ensure a changing world for both IT and operational field. Because what is operational somehow it is not in contrast with, it is not in accordance with the IT. Also, the integration of traditional SCADA operation field systems with IT requires new approaches, new integrated solutions, because it's not so easy to say, okay, it's an island, like we stated in the first picture, then we realize it's actually integrated through a router, maybe somewhere in the middle there is a firewall, maybe there is some identity equipment to verify who's there. So these two worlds are colliding, and they need to be integrated. And finally, security for operational areas has become more important, especially on the critical infrastructure. Up to now, all the attempts, I think even because there have been a lot of examples of Microsoft, I think Azure was cracked some months ago. Somebody hacked into it. But why? For the cameras, through the cameras. Most of the security issues are connected to the, let's say, confidentiality aspect of the data. You don't want someone to take a look at the camera if you placed it in your bedroom. So I don't know what the hell is going there anyway, but the idea is that in SCADA, we are not speaking about confidentiality. We are not speaking about someone taking a look at you when you don't want to. Someone can actually shut down the power. And all the sensors, all the IoT depend on energy. Or even worse, someone could start the power. This is more dangerous because normally if you have someone with a hand on the grid and you power up 110 kV, he will die immediately. So we think that with the Cisco solutions that are in place and with the partners that they are supporting, you can merge the two worlds, the OT and the IT. What we have chosen for our platform, for the S200 software, was the IR809. We have chosen this for a various number of reasons. First of all, it's very compact. It's very reliable for placing anywhere in the field. You can place it at minus 20 degrees, you can place it at plus 40 degrees, and it will run. So it's a very robust architecture. So this is from a hardware perspective. From a software perspective, it is an infrastructure that supports multiple applications. So our applications runs on a Docker container. It can be deployed on this, or it can be deployed on a cloud, for example. But our perspective is that there is too much data coming to the data centers. I fear 20 million devices, 50 million devices, billion, sorry, devices. So we are speaking about huge amounts of data. I think in time it will prove impossible for data centers to handle all this information if they come directly to there. So we went with the approach of having application running close to the sensors, running close to the edge of the network and doing specific jobs. Also, it has native state-of-the-art security. I don't know if Cisco is best in class, but it's probably top 3 or top 5 or top how much you want in security, in what is IT security. By having the application directly on the Cisco infrastructure, you will benefit from best-in-class security for sure. And you, as an operational guy, you will not have to worry about securing your device, because this will be the job of the IT. But the IT guy will not have to worry if his, I don't know, changes in firewalls or changes in the security will affect your equipment, because they are together. They are tested together and they work together. Indeed, it allows also a software which is independent of the specific hardware, because, like we said, it's a Docker container, and this equipment works with Docker containers. And one important aspect is, if you are living in a very agile world, because this is the name of this organization, then you know that it's almost impossible to say what will happen in 10 years. It's impossible to say what will happen in 1 year. So it is important to have functions so that the equipment can evolve. And managing it through a system like Fog Director, it will enable you to have an evolution similar to the smartphone. When you buy a smartphone, it has a function of agenda, call, and, I don't know, messaging. But then you install WhatsApp, and you discover that you need also Twitter, and so on. So you add applications. This is very common to the IT world. But this is completely different when you go to operational. When you go to the operational guys, they have box which does WhatsApp. They have another box which will do Twitter. So this is why the two worlds will have to be merged somehow. Now, what was the philosophy behind our substation, secondary distribution substation server, or gateway, depend how you want to name it? We wanted to create a unique product for the distribution automation. The energy sector and the energy domain is among the most conservative domains in the whole world. Probably oil and gas is more conservative than that, but I'm not sure. They are struggling, which is the toughest. We wanted to make them capable to add software functions in time. So right now, we added SCADA, because SCADA is something they have been done for many years, and they need that. But in time, they will need additional applications, and they need additional software that they don't even know today. And one other aspect was to integrate in a multi-vendor environment. By locating us in a network equipment, not as a software vendor, then we will have to provide connectivity, because this is the purpose of a router. In the end, IR809 is a router. It has to connect. What we did was, instead of connecting only computers, ITs, we connected also sensors, and have applications to connect non-IP technologies to this system. Again, we wanted to have a SCADA system without its own hardware. It is a virtual SCADA system. It's independent of the hardware. It's independent of the vendor. We wanted to do so that we can have large-scale deployments. We are speaking about deployments. Normally, you deploy one substation at a time. One substation generally handles, I don't know, 100, 1,000, 10,000 data points. So 100 sensors, more or less. The general rule was you deploy one at a time. Last year, we had an order of 150 in a single project. Now, the orders are getting bigger. So handling such systems is very difficult. One of our customers actually has a SCADA network that has 2,000 routers, more than the telecom company more than a telecom company in Romania. So this is how typically the SCADA systems look like. They have some equipment that you need to control. They have some IADs, they are called sensors in energy, they are called IADs, meaning intelligent electronic device. So they have some capabilities. Some of them are Ethernet-based, some of them are serial-based. Some are simply electric signals, plus 20 volts, plus 48 volts, depends on the domain, on the country, and the regulation. So you had a local RTU, which was able to read these signals through cable. You had these CIDs, which are able to read currents, to read voltages, to calculate faults, and so on. And then you had a router or a modem, which normally connects through a VPN to a control center. This is standard SCADA equipment. We've seen it in Romania, first time large-scale implementation 10 years ago. So it's not something new. I'm sure that in the EU, in the Western country, it has been around for 20 years. So what we wanted to do is change this. We wanted to get rid of both the RTUs and the router. We wanted to replace it like this. So what we did was decentralize completely the IOs. So we removed the electrical part from the software part completely. We embedded the software for the SCADA inside the router, because in order to control something at a distance, you need a communication device. Maybe you don't need an RTU, but a communication is certainly needed. So we added all the SCADA capabilities in the router, and then we created external modules to read the electrical signals, because the router does not have the electrical inputs that the regular RTU has. This is typically what the data flow looks like. So basically, the ES200 is the substation server. It is responsible of handling all the information acquired through various type of sensors. Generally speaking, we are talking about some, like I said, some thousands to tens of thousands of data points. And the trick about this is that the application handling 5,000 data points has about 25 megabytes of space. Takes about 25 size of space, and I think 6 to 28 megabytes of RAM. So it's a lot of place to improve, to add functions on the router. We don't want to eat all the resources, because this equipment should also work in an emergency, in a storm where all signals will happen at once. Currently, we have running and the operational about 10 units of these devices. All the protocols listed here are specific energy protocols. These are the protocols we encountered so far. Each of them is developed as its own agent. So basically, each protocol is actually an independent application. We have an orchestration layer which manages to check whether there's something wrong with the protocol, to restart it, to remove it from the operation. And we have a control software to configure it through Windows or another machine, because normally the router doesn't have an interface. And the SCADA guys, the operational guys, are not used to the, let's say, to the iOS commands, are not used to configuring routers. So they need a way to easily configure this equipment. So that's why we have a separate software to help them with the configuration. Now, once again, we want to emphasize the fact that this is a multi-purpose use case. We have seen the IT world evolving a lot in the past years, but the operational, the IoT, only now is starting with some small projects, with some big projects. Depends on the size of the country, depends on the size of the company that does the project. What we wanted to do is to have an open platform, which is ready to combine deployment with other Cisco partners or companies that can develop software. Once again, we consider that it's important to be in an ecosystem, because you cannot know everything. When you are speaking about Internet of Things, we have heard from cows, dogs, bicycles, shoes, bracelets, so watches. It's actually Internet of everything. One of the guys, actually the guy who invented the World Wide Web, once in an IoT conference asked, is this Internet of Things another internet or is the same internet? It was not a stupid question. It was a very genius question, actually, because we are speaking about internet. When you speak about internet, you immediately think IP. Most of the things in IoT, especially in the energy, have no clue what the hell IP is. So they are speaking serial communication. They are speaking some Zigbee, some RF mesh, some whatever, wireless communication, not necessarily IP. Now they are speaking LoRa. So IoT is or is not the same internet as the internet, but it clearly has to be in the same place. So at the end, the data from the things need to go online. So what we wanted to do is to allow an application that it's running on the network edge. So basically, this is the last IP device you have or you can place in the field. It will allow connectivity, data normalization, and data aggregation. Because there are sensors which, for instance, you have a welding machine, a big robotic welding machine. That machine will generate roughly 500 to 600 megabytes of traffic per day, all with crap information. It's nothing. It's just saying, I'm here, I'm here, I'm here, I'm here, every time, 2 times a second. So it will create a lot of traffic. If you have a node on the edge, right there, next to the machine, and you read that 500 megabytes of useless traffic, you remove everything that is not useful, and you only send to the Azure cloud what you think is important, then you will not need 500 megabytes of bandwidth. Maybe you will need, I don't know, 10 kilo, because the useful information is much, much less. Last but not least, we wanted an open system to gather data from sensors and equipment, not necessarily SCADA. SCADA is something which is traditionally seen as robust, as reliable, as it works 100% of the time. Like it was the example, previous example with the air monitoring systems. Okay, you buy a system which is €500,000 and you will know exactly the quality of air. This is pretty much SCADA. You buy something which you are precise and you know that it will work. Internet of Things is not necessarily the same, because if you have a smartwatch, you may lose connection to it sometimes. It's not important. However, it has been proven that having 1 million smartwatches reading the temperature will give you more reliable results than 200 very accurate temperature readouts, because statistics works for you. What is the business value behind this? Utilities need flexible operating technologies now, because the investment is growing rapidly. Feeder automation distribution alone, this means from the substation to the house, is a market which is estimated to grow in 6 years from $2.4 billion to $3.4 billion. This is 1 billion, 50% increase in 5 years. So they do not know what will happen. This increase of money will create new technologies, will create new demands. Besides this, we are talking about a regulated market. So the market operators, the customer, require more quality, better services, and so on. So if he goes for this approach, he will have an upgradable system. He will enable software-defined infrastructure directly in his IoT world. Of course, he will have security, he will reduce cost, and it will ensure interoperability with vendors. Now, I would like to speak to you about a deployment that we've done and about the development. The client where we deployed these first units is Electrica. Electrica Muntenia Nord is one of the top companies in Romania. It's part of Electrica, which is the distribution company which handles about 3.5 million customers, roughly 1/3 of the country. This particular area where we played, this is how a SCADA systems looks like. You can see it's almost a data center in its own. Every system is redundant, everything, it has a disaster recovery and so on. This particular system handles about 90 substations, primary substation, and about 500 secondary distribution, and roughly 1,500 switches all over the place in the rural area. What was happening was that their SCADA network was growing rapidly. Like I said, they have now about 2,000 routers in the networks, and they need to manage them, each from another provider, each from another solution. The cybersecurity concerns and demands have increased. Like I've said about Ukraine, what happened there was that, I don't know, about 300 people remained in the dark for several hours. This is currently unacceptable according to EU regulations. So, okay, how do we do that while still keeping open our system, so we're still being able to control it? So cybersecurity is an important thing which we managed to address. The fact that they needed scalable and manageable solution, like I said, from 1 unit at a time, we had a pilot project of 10 units operational in March, then 70 additional units by August. So the rhythm increased exponentially in how they want to install. Just as an idea, until 3 years ago, they had 80 units, 80 such distribution, let's say, gateways in place. 2 years ago, they had 200, and last year 400. Now 170 by mid-year. And our ongoing development consists of, sorry, I see I've stepped over my time a bit, consists about LoRa connectivity, because we see that LoRa is a huge factor for IoT, and developing industry-specific protocols. All the protocols we have developed are protocols for energy. They are very well known in energy, but not so much used in industry. And last but not least, developing horizontal functions like fault installation, fault detection, and rapid restoration. Basically, the equipment will speak to each other and will automatically isolate the fault. Just a quick overview of what we want to do for as a LoRa for a smart grid. Basically, the smart grid consists of these equipments: cities, houses, factories. All these are connected. They need power to work. All these are connected generally to a distribution stations, to distribution stations. So if you would add LoRa on the distribution stations, which generally speaking are close to the houses, 2 kilometers away maximum distance, which is pretty much the same distance as LoRa can cover. So we are speaking about cities. So if you would do that, if you will enable the LoRa to the distribution system, then you could very easily add sensors for the energy. Sensors which have a low cost and they don't have an operational cost. You can add sensors for smart houses. For instance, gas leakage. Romania, almost all households in the cities have gas heating. There are explosions, I don't know, once or twice a year with some building which had problems with gas leakage. So you could do that. You can stop the current when this happens. You can also have multiple meters like gas or water read through the same infrastructure. LoRa infrastructure is not so suited for energy meters, unfortunately. And last but not least, we've seen a lot of this in Romania, a lot of increase in electric cars. You could develop analytics, read the position of the cars, know the status of the battery by using a very low-cost technology in terms of operational costs. So, to sum it up, I think it is time to bring also digitization into operational area. We have spoken of digitization for many years now, but nobody touched the OT area. That was something not to touch. You know, if it works, don't touch it. Well, it's no longer possible because the OT needs to provide information to the IT so that the business models or the business decisions are made wisely. We are no longer speaking about some assets located somewhere. They are connected assets. So you need to apply the same rules in operational areas. Thank you very much, and I'm sorry if I took a lot more than I expected.